The sun goes down over the savannah, and a group of early humans settles onto bare ground. No walls, no locked door, just skin, breath, and 30 feet of open grass between them and a pride of lions they can hear moving through the dark. By every rule of nature, this should not work. Sleep leaves an animal blind, deaf to danger, and unable to run. A sleeping human weighs less than a lion, moves slower than a hyena, and has no claws, no fangs, and no fur thick enough to stop a bite. On paper, our ancestors should have been the easiest meal on the continent every single night for 2 million years. They weren't. And the reasons why tell us something that most people never think about. Sleep was not a retreat from danger. It was one of the most carefully engineered survival systems our species ever built. For most of human history, night belonged to someone else. Lions hunt best in darkness when their eyes gather far more light than ours and their prey can barely see 3 feet ahead. Leopards drag their kills into trees at dusk. Hyenas run in packs after sunset, covering ground a tired human could never match. Every predator on the African plains had better night vision, better hearing, and better speed than the people trying to survive among them. A human asleep on open ground at 2 a.m. was, in raw physical terms, the weakest creature in the landscape. No claws, no horns, no armor plating, just soft tissue and a body that needed 8 hours of stillness to function the next day. So the question is not really why predators didn't attack sleeping humans. Some did. Bones recovered from cave sites in South Africa carry tooth marks that match leopard jaws. Skulls from sites in Georgia show puncture wounds from big cats. Early humans were killed in their sleep, and they were killed while awake. This was never a species that solved the predator problem completely. What they solved was the odds, and they did it through habits so consistent that they show up in the archaeological record across 3 continents and nearly 2 million years. The single biggest shift in nighttime survival came from something almost embarrassingly simple: a flame that could be kept burning through the dark. Evidence of controlled fire at hearths goes back at least 1 million years, with the clearest cases appearing around 300,000 to 400,000 years ago at sites like Kesem Cave in what is now Israel. Ash layers there are thick, repeated, and centered in the same spot over generations, which tells researchers that groups were not just stumbling onto fire. They were maintaining it, night after night, in the same place. Fire did 3 things at once. It lit the immediate area, stripping away the total darkness that let a predator get within striking distance unseen. It produced smoke and heat that most large cats find unpleasant enough to avoid, since a lion's nose and paws are far more sensitive than a human's. And it gave the group something to gather around, which meant bodies stayed close instead of scattering across open ground. Modern researchers studying the Hadza, a hunting and gathering community in Tanzania who still sleep in the open near fires, have documented lions and hyenas passing within 100 feet of a burning camp and moving on without approaching. The animals aren't afraid of fire in some mystical sense. They're avoiding an unfamiliar, bright, smoke-heavy zone where their usual stalking tactics don't work. A predator that hunts by getting close before the prey notices has no good options against a lit fire that turns the element of surprise inside out. This is why so many ancient campsites, when excavated, show a fire pit at the center with sleeping areas arranged around it in a ring. That wasn't for warmth alone. It was architecture, built out of nothing but flame and arrangement, and it worked well enough that the pattern barely changed for hundreds of thousands of years. Here is something that surprises people when they first hear it. A predator almost never wants to attack a group. Lions, leopards, and hyenas are ambush hunters built around one core advantage: surprise. Their entire strategy depends on isolating a target, closing the distance unseen, and striking before the prey can organize a response. That strategy collapses the moment there are multiple bodies close together, because a group means multiple sets of eyes, multiple directions of alertness, and the real possibility that an attack draws a violent, coordinated response from every adult nearby. Early human groups slept clustered, often shoulder to shoulder, with children and the most vulnerable members pushed toward the center and the strongest adults on the outer edge. This wasn't sentiment, it was a defensive perimeter built from bodies, the same basic logic that later showed up in musk oxen forming a ring around their calves or elephants surrounding their young when threatened. A predator sizing up a cluster like this faces a brutal calculation. Attacking a lone sleeper on the fringe of a group might work. Attacking into the middle of a tight circle of 30 adults, several of whom will wake instantly and fight, risks an injury that could be fatal to the predator itself. A broken leg or a torn eye is a death sentence for a lion, since an injured big cat can no longer hunt. Evolution does not favor animals that take that kind of gamble regularly, so the ones that survived to pass on their genes were, on average, the ones cautious enough to avoid it. This is likely part of why solitary humans, off on their own gathering firewood or hunting alone, were disproportionately the ones predators went after. The group wasn't just company, it was the wall. Children occupied a strange position in this system. They were the most vulnerable members of any group, too small to fight, too slow to run, and yet the archaeological pattern shows them tucked into the very center of sleeping arrangements, surrounded on every side by adult bodies. That placement alone likely saved countless lives across the generations, simply because a predator would have had to get through several adults before ever reaching a child. But children also served a purpose in the opposite direction. Anyone who has spent a night around young kids knows they rarely sleep in one long, unbroken stretch. They wake to feed, to cry, to shift position, to ask for water. Every one of those small disruptions added another flicker of noise and movement to the camp at exactly the hours when a predator would otherwise have the best chance of approaching unnoticed. A restless toddler was, without anyone intending it, part of the group's early warning system. There's a detail about human sleep that stands out compared to almost every other primate. We sleep in shorter, sometimes segmented blocks, and not everyone in a group tends to be unconscious at the same time. Historical accounts and studies of surviving hunter-gatherer groups describe what researchers call staggered wakefulness. At any given point during the night, someone in the camp is likely to be at least partially awake, tending the fire, shifting position, nursing a child, or simply lying there with eyes half open. A 2015 study of the Hadza found that across the entire night, there was rarely a moment when every single adult in the group was asleep simultaneously. The overlap of individual sleep cycles meant the camp, as a whole, was almost never fully unguarded. This likely wasn't a formal rotation with someone assigned to first watch the way soldiers do it today, though some groups may have used exactly that system. It was something more organic, different people naturally waking at different points in the night, keeping the fire fed, glancing at the tree line, and going back to sleep. Multiply that pattern across a group of 20 or 30 people, and the camp effectively had round-the-clock coverage without anyone consciously deciding to provide it. A predator studying a camp from the shadows, which is exactly what a stalking lion does before committing to an attack, would have picked up on movement almost constantly. Flickers of alertness, even brief ones, are often enough to make an ambush hunter abandon the attempt and look elsewhere for an easier target. Choice of location did enormous work in keeping people alive through the night, and the archaeological record shows our ancestors were far pickier about it than most people assume. Cave sites like Sterkfontein and Swartkrans in South Africa reveal that early hominins favored shelters with a single narrow entrance, a layout that turned a wide-open vulnerability into a choke point any predator would have to funnel through. A narrow cave mouth meant a threat had to approach from one direction only, which meant it could be heard, smelled, or seen before it got close enough to matter. The Zhoukoudian cave system outside Beijing tells a more complicated version of this same story. Early humans used those caves for shelter across hundreds of thousands of years, but so did giant hyenas, and the bones found layered through the sediment show both species cycling through the same space at different times. This wasn't peaceful coexistence. It was a rotation of danger, where the safety of a good shelter had to be balanced against the risk that something else considered it home too. Groups likely scouted a cave carefully before committing to sleep in it, checking for fresh tracks, droppings, or the smell of a den before ever settling in for the night. Elevated ledges and rock overhangs served a similar purpose to narrow cave mouths. Sleeping above the ground level, even a modest 10 or 15 feet up a cliff face, put people beyond the reach of most ground predators while still leaving an escape route if something climbed after them. Some researchers argue that early tree nesting, seen in chimpanzees today, and likely practiced by early hominins, served exactly this function before humans became more fully ground-dwelling. Wind direction mattered too. Groups appear to have positioned camps so that prevailing winds carried human scent away from areas where predators were known to travel, rather than announcing their presence for miles. This required knowledge accumulated over years of living in one region, passed down the same way people today might warn newcomers about a dangerous stretch of river. None of this was random. A group that camped in the open, downwind of a lion's territory with no barrier and no fire did not get many more chances to make the same mistake twice. Natural selection is a blunt but effective teacher, and the lessons that stuck were the ones written into the campsite choices archaeologists still find today. There's a persistent idea that predators simply don't recognize humans as prey, as if something in our shape or scent makes us invisible to a hungry lion. That's an oversimplification, but it's built on a real pattern worth understanding. Large predators are, broadly speaking, cautious around anything unfamiliar or difficult to read. Human posture, upright and bipedal, doesn't match the silhouette of the four-legged herbivores that make up most of a lion's or leopard's normal diet. Studies of predator behavior in modern Africa have found that big cats often hesitate and reassess when a human stands upright, even in situations where the same cat would attack a crouched or prone figure without hesitation. This is part of why lying flat and still, the exact position of a sleeping person, carries real risk, since it removes the upright silhouette that gives predators pause. It's also why fire, noise, and the general chaos of an active human camp mattered so much. A resting group scattered around a low fire, shifting occasionally, making small sounds, and radiating unfamiliar smoke smells presented a sensory picture that didn't match anything in a predator's normal hunting experience. Unfamiliar meant risky, and risky meant most predators, most of the time, chose to move on rather than commit to an attack whose outcome they couldn't predict. Scent played its own role. Human camps carried the smell of smoke, cooked meat, and dense human activity, an overwhelming and confusing combination compared to the clean scent trail of a grazing antelope. Predators rely heavily on scent to identify safe, predictable prey, and a smoke-soaked human camp simply didn't read that way. The bone assemblages found at a site called Krapina in modern-day Croatia offer a grim but useful window into how often the balance tipped the wrong way. Alongside human remains showing clear signs of processing and butchery by other humans, researchers have also identified marks consistent with carnivore scavenging on bones left exposed after death. Sites like this remind us that safety was never absolute. It was a percentage, shifted a little further in the group's favor by every precaution they took, and shifted back the other way whenever those precautions slipped, whether from exhaustion, poor location, or simple bad luck. Somewhere between 20,000 and 40,000 years ago, a shift began that would eventually make the night far safer, though it happened slowly and unevenly across different human populations. Wolves that lingered near human camps, scavenging scraps and tolerating proximity to people, began a long process of domestication that produced the first dogs. A camp with even one or two of these early proto-dogs gained something enormously valuable, a nose and set of ears sharper than any humans, tuned specifically to detect approaching predators long before a person would notice. Dogs don't need to see a lion to know one is near. They smell it. They hear the grass move differently than it does under a smaller animal's weight, and they react, barking, growling, positioning themselves toward the threat well before the danger reaches the edge of camp. This relationship didn't erase the risk of nighttime predator attacks. It reduced it substantially, adding an early warning layer that no fire or sleeping arrangement alone could provide. Sites with early dog burials, treated with clear ceremonial care in some cases, suggest that the value of this partnership was understood and respected by the humans who depended on it. None of this adds up to some perfect system. Predators killed sleeping humans throughout our history, and pretending otherwise would be dishonest. Fossil evidence from sites across Africa and Asia includes remains with clear predator bite marks on skulls and limb bones, some inflicted while the person was likely alive and immobile. What the record actually shows is closer to a set of odds, not a guarantee. A lone sleeper away from the fire, without a group nearby, in an exposed location downwind of predator territory, faced genuinely high risk. A person sleeping in the middle of a tight group, near a maintained fire, inside a single entrance shelter, with a dog nearby, faced dramatically lower risk, though never zero. Every layer described here, fire, group sleeping, staggered wakefulness, shelter choice, wind awareness, and eventually dogs, stacked on top of the others. None of them worked perfectly alone. Together, they turned what should have been a nightly slaughter into something survivable enough for the species to persist and eventually spread across the entire planet. That's the real answer to why predators so often left sleeping humans alone. It wasn't luck, and it wasn't some special immunity written into our biology. It was a set of habits refined over hundreds of thousands of years by groups who got the details right and passed those details down, generation after generation, until sleeping safely through the night stopped being an accident and became something closer to a craft.